Oh, Flounder. This is the latest in the TechTV webinar series, and we're very pleased today to welcome Adam Dixon from Phytoponics Limited. Adam will be talking about the work that they've been doing with deep water culture and their invention of the HydroSac. So we're very pleased to be organising this event. From our perspective, keen to show how innovation in hydroponics in a relatively short space of time is able to attract real interest and attention, and with the application of research and efforts, we're able to see a case where major funding has been attracted and real success has been made in the sector. So really pleased to welcome Adam today. I'm going to open the floor for Adam now. So thank you very much for joining with us.
Thanks, Luke. Hi guys. For the presentation, so I'll just start sharing the screen. Cool. Can everyone see? Let's have a look. PowerPoint. Can everyone see the screen?
Yep, that's good.
I guess so. Cool. So deep water culture. So I'm Adam Dixon. I'm the co-founder of Phytoponics. So I've got some echo actually. Turn off the microphone. Cool. So yeah, founder of Phytoponics. I founded Phytoponics back in 2016 with a co-founder Luke Parkin. So it was to sort of commercialize some ideas I had for deep water culture hydroponics for commercial horticulture. And I was awarded the United Nations Young Champion of the Earth Prize back in back in 2017 because of the sustainability angle. So the problem we designed the technology to solve was that the vast majority of hydroponic growing these days uses substrates. So it's typically the rock wool or coconut coir based substrates. And it's by far the majority of hydroponic growing. Every year, the substrates have to be sort of thrown away, recycled, disposed of, and there's a lot of problems in sort of sourcing and shipping substrates. For example, coconut husk sounds nice, but it's quite unsustainable in where it's produced in Sri Lanka because they have to wash the coconut husk to extract the salt, because salt damages the crop. So I designed a deep water hydroponic system based around a sort of flexible model. So I'm getting a bit of feedback on the microphone. So the idea is we replace a substrate with a flexible liner that has an integrated aerator. So it enables us to actually grow crops in water. So what it means is we don't need a substrate other than a small amount that we sorry, I'm getting some what I've done is I've muted my speaker, so I might not be able to hear people. Unmute, yeah, sorry. All right, cool. Try this. So what we can do with a substrate-free deep water culture hydroponic growing system is we can control the substrate. Sorry, we can control the root zone environment with pH, acidity, what nutrients are in the root zone. But the key innovation we have is having an integrated aerator. So the integrated aerator sort of bubbles up air from the bottom of the flexible liner and sort of aerates the roots. And that's key for root health because most problems, well, a lot of problems with growing plants, well, in soil and hydroponics is providing oxygen for the roots. Because if you can provide oxygen for the roots, you can have very healthy roots, which uptake nutrients and stay alive. Whereas if you don't have enough oxygen, you get a lot of root death and disease and cell turnover, which reduces yield. So we're designing this for large commercial scale applications. So growing with deep water culture, so far we've done many crops. You saw the photo with tomatoes, and the roots on the right are snack pepper roots, about 1 week in from transplant. but we've also grown things like strawberries. On the left is like I chose this photo because it shows the type of roots. It's lemongrass, so it's got a yellow tinge. But you can also grow things like trees, like this is a rambutan tree, for example. It's a bit like a lychee, but and yeah, this root mass was developed over like 2 years, and to be honest, we learned some lessons from how to grow it better next time. But it just shows that like a wide range of crops are growable. My favorite was, for example, dragon fruit. So dragon fruit's a kind of orchid cactus from I think it's from South America originally or somewhere, and it actually grows extremely well in hydroponics. We got it to flower in one of our trials up in Yorkshire actually. So I want to hopefully bring that back to Wales as a sort of dragon sort of themed thing. So where does hydroponics sit? So for commercial horticulture, for the growers listening and people interested in the space, and it's there are 3 types of indoor agriculture which hydroponics sits in. So the glass house is probably the most commonly known one. So with a glass house, you've got environmental control. These days, typically you use the sunlight, and you might supplement it with some artificial lights with daylight extension. But the vast majority of the light comes from the sun. This is suited to like high value crops. It's quite expensive to set up a greenhouse, about £300,000 per hectare or more. It represents about 19% of global indoor agriculture globally. And it's probably the best long-term solution for growing plants because it's quite efficient over 20 to 30 years of operation. The polytunnel, though, represents about 80% of the indoor agriculture market. And hydroponics has like moved into the polytunnel space quite a lot with crops like strawberries and sort of soft fruits. It's sort of my ambition to sort of expand a lot of horticultural crops into the polytunnel space with hydroponics to sort of benefit from the lower cost of ownership, because a typical setup cost for a polytunnel is less. It's about £100,000 a hectare, depending on the installation, of course. But it's by far the largest representation in commercial horticulture globally. So people might know about the big glass houses and polytunnels in Almeria. There are quite a few innovations which have made it quite a few innovations in the space which have made polytunnels sustainable as well. But in terms of developing countries, it's very attractive. It's suited to the UK as well. Like the majority of soft fruit that aren't grown in the field are grown in polytunnels. And then with other types of indoor farming, we've got vertical farming. So this is a big growing area with lots of investment. It's very capital intense. Typically at the moment, it's only suited to low light crops like salads because the energy cost is quite high to have the lights. And I think it'll be some years until it'll take off as a sort of mainstream thing, but with reductions in electricity costs and grow light cost and efficiency increasing, cost decreasing and efficiency increasing, we'll see more and more of it. But it's best suited to projects that have like large amounts of energy provided, electricity in this case. So deep water culture, just to summarize the sort of scope for it. So because it's substrate free, it can be the parameters of operation can be tuned to most plants actually. The plants you want to grow depend on the market value ultimately. So it's typically suited to higher value crops because it's within a more capital intensive sort of indoor agriculture space where you raise the productivity. For example, it's not suited to grain because grain's grown at a large scale on sort of large fields with combine harvesters. But for example, vine tomatoes or sort of nutraceutical plants are well suited because they're sort of if you increase the yield by 40% or an amount, you get a much higher return on investment with a higher value crop when compared to like an arable crop. And the complexity can range from simple sort of almost rice paddy type installations or systems, like the Aztecs invented a sort of a floating platform which went on lakes, and they grew crops in that called a chapas or something. That was an old type of hydroponics. And then you got the fully automated glasshouse systems in the Netherlands and the UK now, which is like the more complex ones. So deep water culture, it's best combined with either a polytunnel or glasshouse for synergy, because what the deep water culture does is it optimizes the root zone, but you've got to optimize the above plant zone as well to get the sort of real maximum yield. So it's best to deploy glasshouse and polytunnels, especially in projects where you've got waste heat and energy, say for example from sort of biomass boilers or near an energy plant or something. It is a developing sector in the science as well. So the agronomy and the science is a bit sort of it's developing. It's very interesting. That's something I've been sort of personally sort of very interested in pursuing, because growing plants in a deep water culture, it's different to growing plants in a substrate. It requires a different sort of mindset, a different sort of understanding. And once you get it, it's very simple. So culturally, there's a bit of a sort of difficulty in sort of setting it up and getting to grips with it. But once you've got it, you've got a great position to be able to grow crops quite relatively simply. Because with substrates, for example, you have to worry about how wet they are, how dry they are, sort of drying cycles. With deep water culture, because the root zone is sort of uniform, it's with maintained levels of water and aeration to keep the roots healthy. You don't have to worry about wet and dry cycles, and there's a lot larger buffer amount of water, so you don't have to worry about frequency of irrigations as much, if at all, and the temperature is more stable as well. So it's quite suited to it's very suited to sort of arid applications where you've got cold nights and hot days, and it helps balance out the sort of plant root environment. So so that's the sort of end of my presentation. Had a few points on sustainable intensification, but I'm sure questions will be asked. So I'll I'm available available to consult. Phytoponics supply the deep water culture system. So any questions, please reach out to me, and my email is just adam@phytoponics.com. We can strike up a conversation, and we can look at some exciting opportunities. Cool.
Well, thank you very much indeed for that, Adam. That's really interesting.